So I'll let you know. Okay.
Excuse me, ma'am. I have also another doubt.
Yeah, yes.
Will we get questions in the quiz one regarding two functions like f of g?
Yeah, I mean, onto means surjective function, right? Yeah, there will be questions regarding 1 onto functions in your quiz
No,
one.
I meant like we will be given two functions f and g, and we have to find something related to them. So questions like these.
Yeah, we are going to ask about finding the domain of function, composition function, finding the not composition function. Composition function will come into week 6. So in quiz 1, there will be question based on obviously
Only
bijective
one
functions,
function.
domain of function, and range of functions. Yeah, only one function.
Okay,
Yeah,
thank you.
matlab one variable function.
Yes, thank
Ma'am, will you teach from domain, codomain, and all?
Yeah, I'll start with the basic, whatever the basic definition of function, and then we'll move on to one function, onto function, bijective function. And after that, I'll give you little tips on how to draw a graph. If you know some graph, and then if you want to scale it, that thing I can teach, or else we can left. Yeah, I think we will go with the graph in week 3. There will be equation of lines and quadratic function. So in week 2, week 3, I'll teach you how to draw a graph. That will be more appropriate. Here we just go through the definition of function and bijective functions.
you. Your
And
voice has a
after that,
bit
I
of
will
echo.
take. Okay, it's echoing.
Ma'am, it's live on the YouTube now.
I think it is streaming now. Hello, am I audible now?
Yes, ma'am, you are audible.
Yes, ma'am.
Yes.
Is it fine now?
Absolutely.
I have a problem on some of activity question.
Yeah, so after this, I'll go to activity questions only.
Ma'am, please tell the time from when you will start taking the question.
Mostly 8:45. I'll spend 30
Okay, ma'am.
minutes on two definitions. After that,
Okay,
I'll
ma'am.
go to it.
Okay, ma'am.
Yeah, just wait for a couple of minutes. There are very less student now, 100 or something. You guys are getting notifications that today is your session, right?
No.
You're not getting
No,
any.
I got it from
We are from
calendar.
calendar. Like we have received calendar.
No, ma'am, we have to see you in the calendar. No, yesterday we got the mail.
Yes, ma'am. We got the mail about the session.
I guess we
Yeah,
got
mail.
to set
I
the
Yes,
didn't
settings
get
in the
any mail.
calendar. We need to
yesterday
update
we
the
got.
settings
I
in the
didn't get any mail,
calendar.
ma'am.
Speak one
Today.
moment.
I
Yeah,
joined
there's
from
no
calendar.
notifications. I mean, we just have to access the calendar.
Okay. So you have to access the calendar. That means you have to track down today's session. Okay.
Right now,
Also, ma'am,
status
when
check
is the
also going, madam.
mentorship getting started?
Ma'am, I joined from calendar.
Calendar is the best, ma'am.
Okay.
Status
Ma'am,
check
when is the
session also going on,
mentorship
madam.
getting started?
Mentorship.
For maths one.
We have mentors now. I'm not sure about. I think after second week, you can assume that you will get your mentors because they haven't give us any instruction about mentors. TA session was TA session already has been. I mean, one or two. Today's in the morning there is one TA session, right?
No, ma'am.
Yes.
Yes, ma'am.
I think it's
No.
Yes.
Actually,
The link was there, but
No, ma'am, that's not
attended.
it's just
available.
not
Only the
joined.
It
student.
got cancelled, ma'am.
There was one, but it got cancelled.
Okay, it got
That's
cancelled.
what I'm saying.
Yeah,
Yes.
no one joined.
No one joined. That's why it got cancelled. Is that the case?
I
No,
think
no,
the
students,
link was not
students,
Just one by one.
TA was not
Hello.
there. TA was not there.
students
He is
joined it.
not there.
Please just yeah.
Yeah, students were there.
But the link is also
Okay.
missing from the
Yeah,
calendar.
but we did get a
When I
mail
see
from
it
the
now.
IIT that the event got cancelled, that the session got cancelled. We did get
Okay.
mail about that.
Acha, you did get.
No, we got it. We got the mail.
I didn't get it.
Ma'am, can we start?
I don't got.
Yeah, I'll start. Okay, fine. I don't think people are going to come. Fine. So let's get started. I'll mute you all. Okay. First, introduce you the definition of function in my perspective, how I understand the functions, and then I'll unmute you, and then we can discuss whatever doubts you have.
Okay.
Okay, so what is a function? So function, you can assume it like a machine, which can take inputs from some set. That's why we define set first, and after that we come to function. So what does a function do? Function will take some inputs from a set and give us some output to some another set. Suppose this is your set, set A, and this is your set B. So what does a function do? So function act like a machine. So it just take input from this set and give us some output over this set. But it actually, it follows two rules. What is the rules? First rule is that every element of A, every element of A should get access as an input. That means we say f is a function from A to B. That's how we write it, that f is a function from A to B. If every element of A, or you can say that for every element of A, for every A in A, this is one rule, that for every element of A should be, we are allowed to get, we are allowed to accept that A to be an input. Then only this map or this correspondence or this machine, we call it as a function. So first rule is that every element of A should be mapped, right? So we say f is from A to B is a function, if for every A in A, and the second rule is there exists a unique B in B in such a way that f will take A as an input, small a as an input, and give us small b as an output. So that means f, if you have, if some map is given to you, some map means some correspondence is given to you, or some rule is given to you, how you will judge it is a function or not? So first thing is, whatever set is here, you have to take every element, you are allowed to take every element of A as an input. Then only you can say that, okay, it can be a function. The second thing is, for every input, you should have a unique output. If you are getting two outputs, then it's not a function. Okay, so the definition of function look like something like this. If f is a map from A to B, then is called a function. Again, the same thing. If for every A in A, there exists, this is sign for there exists, you guys can learn now, there exists an unique B in B in such a way that f will map A to B. Okay, so I'll start by very basic example. So this is our definition. So what we want a correspondence or a map or a machine which will take input from a set A and give us an output onto the set B, and it follows two rules. First rule is every element of A should be taken as an input, and the second rule is for every input I want a unique output, not more than one output. For example, if I give you one correspondence with the finite set, suppose this is your set A and it has three elements, let's say 1, 2, 3. Okay, and another set is B and it has four elements, A, B, C, D. Okay, and if I give you a machine or a map F from A to B in such a way that F will send 1 to A, 2 to B, and 3 to C, then this map actually following my two rules, because every element of A can be taken as an input, right? So that means every element of A has an image in B, right? And it has a unique output, because 1 is going to A, 2 is going to B, and 3 is going to C. That means if I take one input, then I'll get a unique output, not more than one output, right? So that means this map is a function. Whereas if I change it, if I change this thing a little bit, that means if I say that I have inputs to be 1, 2, 3, and I want my outputs to be A, B, C, in such a way that one maps to A, one maps to B, and one maps to C, and then 2 can map to B, and 3 can map to C, then this map is not a function, right? Is not a function. Why it is not a function? Because here we don't have unique output thing, right? Because f of 1 can be equals to a, f of 1 can be equals to b, and f of 1 can be equals to c, right? So that means for one input I'm getting 3 different output, which I don't want if I am saying that my map or my correspondence is a function. Okay. Similarly, if you take another example where I miss the uniqueness, here I miss the uniqueness of output. If I say that, suppose this is your set A, and I am giving you one map F from a set A to a set B, again I will take the same things, A, B, C, in such a way that this map actually maps 1 to A, 2 to B, and that's all. Now, again, this map, this F is not a function. This is not a function. Why it is not a function? Because again, it is not satisfying the input property. That means for every element of A, there should exist some output, right? That means every element I'm not able to take this 3 as an input in my this function F. That's why it's not a function. So what is a function? Function is basically a rule, a map, or a correspondence, or anything you can say, which follows these 2 rules, and it's from one set to another. A function is defined from one set to another, and it follows these 2 rules. First thing is, for every element of A, there exists a unique element of B. That means every element of A can be accessed as an input, and the second thing is, for every input I have a unique output. Okay, so these are the 2 rules which function if a map follows these 2 rules, then that particular map is known to be a function. Okay, now the next thing is, a function is also a relation. That means if we have a function, so suppose f is a function, suppose f is from A to B is a function, then for every function you can define a relation. So that relation is denoted by R of f. So this relation is nothing but, again, we know that the relation is nothing but a subset of A cross B, right? Here my set is A, B, that's why I'm taking A cross B. So for every function we can assign a relation, and that relation is denoted by R script f. And this relation is nothing but containing all the tuples A comma B in such a way that f of A is equals to B. That means f takes A to be an input and give us output to be B, then these 2 elements A and B are related. And this function is known to be the, associated relation to our given function. So that means every function is a relation, but the converse is not true. Okay. And the second thing is, as we know that every relation we can plot. So that's why for every function, we can have a graph of every function. So suppose I have a function. Again, suppose I have a function from A to B. Then you can graph this function. We can graph this function using our R cross R plane. And here I'm assuming that A and B are subsets of real numbers. Then only we can use real lines. Okay. So suppose this is your x-axis and this is your y-axis. So then any point you can mark a dot there, or you can put a point there where the function takes A to be an input and f of A to be your output. Okay, so in this way you can draw a graph of every function. That's why we say that a function can be represented by either their expression or their graphs. Okay, so this is a basic definition of function. So I'll unmute you guys, and if you have any doubt in definition of function, so we can discuss it. Okay.
Ma'am, does every relation is a function?
No, every function is a relation, but the converse is not true. Because suppose I'll give you a relation. Suppose I'll give you a relation. So it's a relation from A to B. Suppose my set A is nothing but, again, 1, 2, 3 I'm taking. And B is nothing but A, B, C. Okay. So now if I give you a relation R in such a way that I'll say that 1 and A is related, 1 and B is related, and 2 and C is related. Now this relation, you can't say that this is function, because for one input I'm getting 2 different output, right? One is also related to A and one is also related to B. But whereas if you have a function and if you define that relation RF, then this thing won't happen, because function follows 2 rules. For every element I have an output and a unique output is there. Okay.
Ma'am.
Okay.
Input,
Yes.
one output.
I had one doubt. Ma'am,
Yes,
there is one question, not graded section 1.95, which says all x
okay.
is mapped to R. and the domain is real numbers and x is also real numbers. But there is one option which says which of this is injective. So which means one on one. So it says f of
Okay.
x square root of 10
Okay, we
minus
will
x.
discuss that. We can discuss that later on. I'll come to the activity part also.
Yeah.
Okay.
Ma'am, what if
so
we have
Ma'am, can you please
the
repeat
same
the
output
relation part?
for two different inputs?
yes, what you are saying?
What if we have the same output for two different inputs? Will that be a function?
That that will allow. I mean, for two different input, you can have a same output, because here these two properties is not violated, right? For every input you have an output, and for every input you have an unique output. This input should not get mapped to two different output. Input should not get mapped to two different output. This is not a function. This is not a function. But if you have two different input, suppose you have two different input x1, x2, and they can map to a single output, let's say x0. That's allowed. This is allowed in function. But if you have an input, then that input should get mapped to a unique output, not different output. Yes.
Ma'am, for mod function,
Ma'am,
there
can
exists
you
a plus
please
or
repeat
minus
the
for the
definition
answer
of
guide, ma'am.
Wait. Now you guys will raise your hand and then I will unmute you. Otherwise. Yes, sir, I will.
It's a viral, ma'am.
Aviral,
Can
sorry,
you
sir.
can you please
go.
repeat the definition of relation?
Sorry, what?
The definition of relation.
Okay, relation part. So suppose you have a function f from a to b. So then for every function, you can assign a relation. And that relation is denoted by rf. So it's nothing but you have to take first, every relation you have a pair, right? A comma b. So here a is your a and the second one will be your f of a, right? So this is your relation. Because again, it's a subset of a cross b, right? So it's a relation. That means for every function, we can define a relation. But every relation, the converse is not true. So if you have a relation, then it is not necessary that that relation can be associated to any function. Okay, this way is not possible. But for every function, we can say that there exists a relation which actually give us all properties of a function. But the converse is not true. Okay. Yes. Yes,
Ma'am,
Lokesh.
for mod function, there exists a for output, there exists a plus or minus at the output, right now, ma'am?
So mod is a function because therefore one input we are getting only one output. Now, see, if you define f of x to be mod of x, and if you take f of 1, then it's equal to 1, and f of minus 1 is also equal to 1. So as I say, that two different input can get mapped to one output. That's allowed. But but one input cannot give us two different output. That's not allowed.
Ma'am, some in cases, if we remove the mod to the x, then we can write the x before plus or minus, right now, ma'am?
Sorry, what?
If we remove the mod to the x, ma'am, there is a function f of x equal to mod x, right now, ma'am. If we remove the mod for
This
that
actually,
x,
if you remove the mod na, this function denoted by this, it will be x when your x is greater than equal to 0 and minus x when your x is less than 0. That's how this mod function removed. That's a particular definition. It's not same as plus minus of x. No, it's not that. It is when x is greater than 0, that function will behave like an x. And when your x is less than 0, then your function behave like an minus x. That's how mod function actually divide into piecewise function. Okay.
Okay, right. Thank you.
Okay, yes, Kishore.
Hello.
Yes.
Ma'am, you said that all the inputs in domain should have a specific output in codomain.
Codomain.
But
Right.
it's possible, right, that some elements of codomain cannot be the output.
It is possible. Yeah, it is possible that some element cannot be an output. That's why we define one onto functions, right? Because
Okay,
when
ma'am.
your codomain is same as your domain, then when your codomain is same as your range. So I'll discuss that later.
Okay, ma'am.
Yes, Ayushman.
Ma'am, I had a doubt in activity question 1.6.
Okay. Yeah, I'll go to that later. I just have 2 to 3 definitions. First, let me go.
Okay.
So let's. I hope you guys are familiar with definition of function. Please lower your hand if you don't have any doubt, and then we'll move to 1 and onto function. So before that, I'll introduce what is the domain of function, codomain of function. So suppose you have a function from A to B, then this set A is known to be the domain of function, and this set B is known to be the codomain of function. Now there is one specific set named to be the range of function, range of f, and this is a subset of your codomain. And what is this set? This is nothing but the collection of all elements from your codomain which has a input, which is associated to some input. That means all B belongs to B in such a way that there exist in A in A and such that f of A is equals to B. So that means from your output set, you have to collect all those elements which are associated to some input in your domain A. For example, here, if I give you one small, let's say A and B are A and B are sets, and I have here 4 elements. And if these elements get mapped to A, B, C, and suppose this is my function. This is going to 1, this is going to A, and this is going to A also. Okay, so now what happened here? Codomain set is this set A, B, and C. But here this C does not have any input. I mean, the C is not have any pre-image. Pre-image means it is not associated to any input in our domain. So that's why this C won't be an element of our range. So if you consider this to be our function, then obviously it is a function because every element in our domain has a output, right? And it has a unique output. So that's why it is a function. And the second thing is here this C is not associated to any input. So that means if I say what will be your range of f, so then the range of f is nothing but only A and B. It will contain only 2 elements, A and B. So that's the difference between range and codomain. That's why we define that's why we define domain, codomain, and range. Now there is one thing I have to mention, that suppose if a function is given to you and someone asks that find the domain of that particular function, right? So if some question comes to you that find the domain of function, find the domain of f, then what you will do, you have to find out all those elements which are eligible for your input, right? So that means you have to find all those x belongs to real numbers, or all those real numbers which are eligible, which can be taken as our input, For example, if I give you a function that means f of x should be well defined. This should be well defined. Well defined means it should not be equal to infinity or something like that. That means it should be well defined. So I'll give you a very basic example. So first thing is this function. So suppose f of x is equals to 1 by x, and someone asks you that find the domain of f. Find the domain of f. Then what you will do, you have to find out all those real number for which my function is well defined. Well defined means it makes sense. Some finite quantity you have to get. But here you observe that if you put x is equals to 0, then what you will get? Then your f of 0 is equals to 1 by 0, and this is not well defined, right? It is not well defined. So, and if you take x not equals to 0, then you know f of x is equals to 1 by x, and it's some finite quantity, right? It's not an infinite quantity, or it's not something we cannot justify, right? So that's why the domain of this function will be, so thus what you will get, domain of f is nothing but all real number minus with singleton 0. Okay, so this is a very basic example which will help us to identify how we can find out the domain of a function. So if someone asks you that find the domain of particular function, what you have to do, you have to take the all real numbers and you have to judge which real number cannot be taken as an input, or which real number if you assign in your function, you will get some either some infinity or it is not well defined kind of thing. For example, if I take another function, so suppose I'll take f of x is equals to root x. Okay, and then I'll say that find the domain of function. Find the domain of f. Then what we have to do, again, we have to find out all those real number for which my function either does not make sense or it is coming out to be an infinity number. Okay, so here you observe that if you take any negative number, then we know that the negative square root is not well defined. And here also we want our range, our codomain to be the real numbers. We don't want it to be a complex number or something, right? We just want it to be real number. So here, if you take x to be any negative real number, so suppose x is equals to -1 if I take, then we know that f of x is equals to under the root of -1, and it's not a real number, right? So that means for -1, my function is not well defined. So that's why this -1 won't be in our domain. As the case with the -1, any negative real number if you take, that won't be in our domain. So that's why thus the domain of function will be, domain of f will be what? All non-negative real numbers. So that set is actually denoted by r plus. So r plus is nothing but all real number greater than or equal to 0. Okay, so this is known to be an r plus. So that's how we actually compute the domain of function. Okay, now is there any doubt on domain of function? You can raise your hand. Yes, Kishore.
Hello, ma'am. Am I audible?
Yeah.
Okay, ma'am. I understood the concept of domain and function, but I'm so sorry. I had some doubt on about the relation part that you explained earlier. So,
Okay. Yeah, what's your doubt?
yes. So about the relation part, ma'am, you said that a function can have sorry, a relation can be a function, but function all the function cannot necessarily be a relation. Is that correct?
No. You're stating it conversely. I said that for every function, you can assign a relation which actually denote all the properties of function, but every relation cannot be a function. A function can be a relation, but a relation cannot be a function.
I see. And I have trouble understanding the concept of relation. Can you give one example, like a real time example that will make it more easier to understand?
Real time. I mean, you want an example for this concept, function relation.
Yes, exactly. Function relation.
Okay, so a function is a relation, but not conversely. So suppose I'll give you a function f of x is equals to if I take x squared, then that's also square root of x. If I take this to be my function, then this is a function on obviously close interval 0 to infinity, right? All members between these, you can take it to be a function. But whereas if I define the relation in this way, that x and then square root of x, but that also, okay, so we know that every function is a relation. So if I have a function, then it's obviously a relation. I can give you a finite example, but this particular infinite example, I don't think. So suppose you have a relation R to be as same as I given to you, but suppose I'll give you a relation, that parents relation or the father son relation. Okay, suppose you have a relation R on a set of peoples, that A is related to B if A is a father of B. Okay, now this relation, you cannot say that it is a function. It is not a function, right? It is not a function, because if I say that if I give you one parent, you cannot immediately says that okay, this particular guy is the son of that parent. There could be multiple choices, right? I mean, if you want to assign one parent and one son, that uniqueness is not there. That's why this is a relation. But if you define it as a function, suppose I'll say that f is a function from set A to set B, where set A is also set of peoples, and set B is also set of peoples. And the function is mapping that any A is going to their children, that A is a parent of B, right? Then if you define this f, this map like this from set of people to set of people, then this is not a function, right? Because it is possible that two peoples here are related to exactly one parents. I mean, there could be two brothers or two sister or one brother sister who has the same parents, right? So that means this kind of thing is not a function, but it is a relation, right? Because obviously we can easily define a relation in such a way that A is related to B if A is a parent of B. But this if you define it as a function, then it's not a function because of the unique output thing. Is that fine? Okay. Okay, so I'll mute everything. You can ask your.
Good evening, ma'am. I have doubts from activity 5.
Yeah, all activity doubt I will take after this. I just have one onto function and then we'll go to activity doubt.
Okay, I
I'll just go
joined
one.
late. That's why I'm not aware of it. Thank you so much.
Okay, fine. Yes, Aryan. Sorry.
Am I audible?
Yeah.
Ma'am, I'm attending Saturday's class. Can you please little bit revise all in summary?
Saturday class summary?
No, ma'am. Today's class in summary. I'm little bit late because I'm attending Saturday's
Okay.
class.
So we just have discussed the definition of function and now I'm discussing the domain codomain range concept. That's all. I mean, for previously I defined what is a function. So function is nothing but a rule from a set to another set, which actually obeys two things. First thing is for every input, and I mean every element of A you can take as an input, and that should be associated to a unique output. That's a function. And then we say that this A is called the domain set and B is called the codomain set. And whatever element of B, that means whatever element of codomain has a input or has a pre-image, that all collection is known to be the range of a function. And now we are just discussing the domain of how we can evaluate the domain of function. Okay. Yes, Uday.
Am I audible?
Yeah.
Yeah. Just a basic question. Can you like walk us through important signs, right? Symbols that are using, like most of them we know, but like, can you walk us through the signs? If not now, sometime when you have.
Yeah, sure. As I'll give you one. I mean, whenever I write it, actually, I'm very habitual to write the signs. I mean, they exist for all these all signs. I'll let you know time to time.
Okay. All right. Yeah. Okay.
Rohit, you can unmute yourself.
Hello, ma'am. Am I audible?
Yes.
Okay. Ma'am, you said that in the function of domain, x cannot be x cannot be lesser than 0. It
Right.
can only be 0 or greater than 0. Is that correct?
Yeah.
Right. Is this applicable universally, ma'am? In all
No, this
aspects of
is
function?
this is for only the square root function, because we know that the square root of a negative quantity is not well defined. That's why we are excluding the negative real numbers.
Okay.
Otherwise, I mean, the domain of function depend on whatever function expression is given to you.
Okay, so that can
Is
change
that fine?
accordingly. Yes, ma'am.
That can
That can
change.
change accordingly.
Yes.
Okay,
For
ma'am.
example, here I have given you simply x. In place of x, if I replace it with x minus 1, then what happens? So if x is, if x minus 1 is negative quantity, that means x minus 1 is less than 0, means x is less than 1. So if you take any real number which is less than 1, then my square root is negative. So in that case, the domain of function will change from all real number which are, all x which are greater than or equal to 1 in place of 0. Okay, so it's actually depend on your expression inside the
Okay,
square
ma'am.
root.
So the domain of function can only have real numbers. It cannot have complex numbers. Is that correct?
Yeah, it cannot have complex number because we are studying functions from real number to real number.
Okay, ma'am. Understood.
Yes, Nikhil.
Ma'am, if we are including 0 in root x function, we should put a plus sign in bottom of R.
Okay, that's okay. That's a convention you can put in place of whatever. It's okay, fine. Anything else you have?
No, thank you.
Okay. Yes, Karthik.
Thanks, ma'am. You mentioned that range is like the codomain may
Subset
have
of
more
codomain.
elements. Yeah, subset of codomain. Okay.
Yes.
Sometimes it is becoming difficult to interpret the questions in the
Okay.
activity as well.
Hmm.
In terms of the comprehension that they are given. Let me just refer to my notes. I've just written certain things. 1 minute, ma'am.
Although, see, finding a range of a function is a very difficult task. For domain, you just have to eliminate some elements, but finding the range is actually a very difficult task. If you have given a graph of function, then you can easily say that what is the range of function. But other than that, it's actually your intuitive. There are several methods you can say. I'll just go through that also.
Okay,
So
so
suppose, yes.
Sorry, if I may say this right. During this course, somewhere I've seen this. They are defining the domain of a function as x belongs to R, whereas f of x belongs to R. So how do I
Yeah,
interpret
right.
this, right?
So that means they want you to select all those real number for which your f of x, that means the value of function at that point, should be a real number. For example, if you take f of x to be 1 by x, here if you put x is equals to 0, then we know that 1 by 0 is not well defined. We say that sometimes it is equals to infinity, but actually it's just a sign. Okay, infinity is not nothing. We say that it is not well defined. So that means it's not a part of a real number. Similarly, square root also. If you take -1, then it's not a part of real number. So that's why they define domain like that. You have to select all those real number for which your output or the value of function should be a real number.
Okay, noted. And I'm always getting confused. A number divided by 0 is equal to 0, or a 0
No, a
divided by
number
number is...
divided by 0 is equals to infinity, they say, but it's
Okay.
just a sign. But for time being, you can look at this.
Okay. And
Because they say
0
yes.
divided by a number is a 0?
0 divided by any number is 0. Because we say that 0 is multiple of 0 multiplying with 1 by c. That's why it's equal to 0. We
Okay,
know that
got
if
it.
we multiply by 0 anything, then it's 0. So that's why this is 0, but this is infinity or not defined.
Okay. And if time permits, if you can tell me one more time on the onto function. I'm a little confused over there.
Yeah, I'll go to 1 and onto function now only.
Okay, thank you.
After this one.
Thank you, man. That's all I had.
Yes, Lokesh. I think we are done, right? Yes, Lokesh.
Is there a chance to get a number on range other than the codomain?
Is there a chance to what range?
Is there any chance to output, ma'am? I'm talking about output other than the codomain. Is it referred as a function or not, ma'am?
I'm not getting your function, but yeah, if you have a function from A to B, then B is codomain, but there is some possibility where range and codomain are same, so that will be a function.
I'm talking about if I get a output other than the codomain, is it considered as a function or not?
No. Because that cannot happen. Whatever output you will get, that output automatically go into your codomain. Because codomain is what? Codomain is the collection of all possible outputs. So it is not possible that you get some output and which is not in codomain. That can never happen. Okay.
Okay. Thank you.
Yes, Akansha.
And my question is, as you explained in the question above, like the way find the domains, is there any questions where you can find the codomains of the respective that you have solved?
Okay, see, we never want to find codomain because codomain is depend to person on person. For example, if I give you one function, suppose I give you the f of x is equals to 1 by x, and I say that this is a function, obviously my domain is fixed, the real number minus all 0. But I can give you codomain can be anything. I'll give you r, I'll give you r plus, I'll give you r minus. I mean, it's depend on my choice, whatever I want it to be a codomain. But here, obviously, if I restrict my codomain to be r plus, then my domain will change. So we never want to find out codomain. This is not a appropriate answer, although I mean this is not a good example for answering this question. You can take suppose I'll take f of x is equals to x square. This will be fine, right? So if I take f of x is equals to x square and I'll say that this is my function from real number, because again x square is well defined for every real number. If you take any real number, that square will be again a real number. So this function will have domain R, but the codomain is actually depend on my choice. I can take it to be the full R, still it is a function. I can take to be R plus, now still it is a function because I know if I take any real number, then the square of that real number will be positive. I can take all the real number, all the R plus union with the minus 1. This is also my codomain. So that's why codomain actually depend on person. What he or she want to define codomain, but the range of function is fixed. That's why we always want to find out the range of function, not the codomain. So this codomain is not unique. It's actually you can say the personal choice. If someone wants to define a function from real number to, they can take codomain anything if they want. Okay, that's why we mainly focused on range. What are the exact outputs? Codomain is the set of possible outputs, but the range is actually the collection of all outputs which are, which we will get if we perturb our inputs, right? So because range is what? So range is all the B belongs to codomain in such a way that there exists an A belongs to your domain such that f of A is equals to. That means exactly whatever outputs we can get, that all collection is our range. But the codomain actually depend to person to person. Okay, is that fine?
But in simpler words, we can say that the question is domain and the answer is range, and the codomain is answers along with some extra answers, right?
Right. Codomain is not unique. So if no one asks you what is the codomain of function because they know it's not a unique. You can get multiple answers for that.
And if somebody asks codomain, they will provide the range from where we have to choose, right?
Then they have to provide something. Some additional information should be there.
Okay. Thank you, ma'am.
Okay. So, yes. Next.
Yeah. Hello.
Hello.
Am I audible?
Yes.
What is the domain for 1 minus x square? Root of 1 minus x square. What is the domain?
Root of 1 minus x square. Okay, it's not a question from. Okay,
No.
so here you have to check that this quantity should not be less than 0, right? That means this quantity should be greater than equal to 0. That means your 1 minus x square should be greater than equal to 0. So now you can factor it out, right? This can be written as 1 minus x and 1 plus x. Now it's depend on your you have to observe here if you take the value less than 1 or something like that. Here we use one I think you guys are familiar with that method or not. There is one wave method which actually give us the intuition that if we have some kind of inequality, then how we can find out the x. Find the x which follows this inequality. So that means what we have to do, first we have to change it into the minus of x minus 1 into x plus 1, and now this is greater than equal to 0. So that means x minus 1 into x plus 1 is less than equal to 0. So then what you will do, you will put your roots here, minus 1 and 1. And since the sign is positive here, so that will be positive, negative, positive. And you want negative sign, so this will be your region. So that means the domain will be from minus 1 less than equal to x less than equal to. This is known to be the wave method, or I guess you guys are familiar. I mean, this method is in 12th, 11th. I'm not sure, but I'll teach you if you guys don't have any idea about that.
Okay. And when you
That's how we
say,
have to find.
yeah, when you say f of x belongs to real number set, indirectly it means a codomain is real numbers, right?
Indirectly, we always assume that the codomain is real number.
Okay. Fine. Thank you.
Fine. Now I'll move to injective, bijective function. And after that, I'll start activity and then we'll take our doubts. Okay. Yeah, this method is actually on 12th, I think so. But if not, then also I can revise it because it's very useful when we have to judge domain, codomain, and range also. Okay, so now let's go to 1, 1 and onto functions. So suppose you have a function. So suppose f is a function from a to b. Then we say that f is a 1, 1 function if x1 not equals to x2 will imply f of x1 is not equals to f of x2. That means if you have two different input, that two different input should get mapped to two different output. It is not the case you have two different input and they can get mapped to same output. For example, if you take f of x is equals to x square, then here if you can easily observe, and suppose this is my function from real number to real number, then here you can observe that f of 1 is equals to 1 square, which is equals to 1, and f of minus 1 is also equals to minus 1 square, and that's also equal to 1. So that means for two different input, 1 and minus 1, I'm getting the same output, which is equals to 1. Okay, so such kind of function is not a 1, 1 function, not 1, 1 function. Okay, so the name is there, right? 1, 1. That means for every for different input we want different output. That's a 1, 1 function. Yeah, I'll teach view methods. So this is a basic definition of one 1, 1 function. Now I'll teach you the way how you can judge it is a 1, 1 function or not. So first thing is how to check. It is 1, 1 or not. Okay, so first thing is by finding counter example. So what you have to do, so this is a counter example you can find. For example, as we go via the f of x is equals to x square function, this is not a 1, 1 function, not 1, 1. How we judge that? We simply take, we simply find out 2x1 such that x1 is not equals to x2, but f of x1 is equals to x2. Right, so this is a one way you can judge a function is 1, 1 or not. Second thing is you can use this expression which says that if x1, you can prove it that a function is 1, 1 or not via this expression that x1 not equals to x2. So this you assume that this is your suppose x1 is not equals to x2, and then you have to conclude via some multiplication, division, addition, something like that, f of x1 not equals to f of x2. If this statement is true, then you can easily say that f is a 1, 1 function, right? Because for different input, we are getting different output. So 1, 1 means for different input, you have to get different output. Okay. And the third method is this is actually a count. I mean, you can say negative of this statement. Here, what does it say? If you take different input, you are getting different output. This statement I can rephrase it. So suppose you are getting, if you have the same output, then your input should be same. That means if f of x1 is equals to f of x2, if you assume, then you have to conclude that x1 is equals to x2. Okay, so these are the two methods which will help us to prove a function is 1, 1. So suppose you are not getting any counter example via so many experiments. Suppose you put so many values, but you are not getting anything counter which will counter our thing that it's not a 1, 1 function. And then eventually you have to prove that it is a 1, 1 function. So for proving, you have to use these two methods. Either first you assume that you have two distinct input and prove that you have two distinct output, or the second thing is assume that you have the same input and prove that assume you have a same output and prove that same input. Okay, so I'll take an example here which will elaborate these two statements. So I'll take very simple examples. So suppose you have a function f of x is equals to 3x plus 2, right? So this is a function, and intuitively I know that, okay, this is a 1-1 function, but again we have to prove it. So how we can prove? Yeah, so the definition of 1-1 function is, so function is said to be 1-1 if for different input we have different output. That means if x1 not equals to x2, then this should imply f of x1 should not equals to f of x2. So 1-1 means we should have something like 1-1 correspondence. This is a input, this is output, so something like this should happen. In picture you can imagine such kind of image. Okay, this is known to be 1-1 corresponding, one input and one output. That's why it says 1-1. Okay, so that's a definition of 1-1 function. And how we can check it a function is not 1-1? First thing is obviously counter example. If you are getting any counter example, then you can say that, okay, function is not 1-1. But if you are not able to find any counter example, and eventually if you have to prove that, okay, this function can be a 1-1 function, then you have to use these two phrases which are written in point number 2 and 3. Okay, so here is one example that f of x is equals to 3x plus 2. So now I want to prove that this is a 1-1 function. So what I'll use the second number phrase. So what does second number phrase says? If x1 not equals to x2, then I have to conclude f of x1 not equals to f of x2. Okay, so now this is my hypothesis. I have to take this and conclude this. So that means x1 not equals to x2. So now if x1 not equals to x2, then 3 multiple of x1 is also not equals to 3 multiple of x2, right? And that means 3 multiple of x1 plus 2 is also not equals to 3 multiple of x2 plus 2. And what is this? This is the value of f of x1. So that means f of x1 is not equals to f of x2. So this is a one way you can see, you can show that your function is 1-1 function if you are not getting any counter example. Okay. And similarly, same example I can prove via using phrase number 3 also. So what does phrase number 3 says? Phrase number 3 says, assume that f of x1 is equals to f of x2, f of x1 is equals to f of x2, and prove that x1 is equals to x2. So if I assume this thing, f of x1 is equals to f of x2, so that means I am assuming that 3x1 plus 2 is equals to 3x2 plus 2. Right, now 2 and 2 will get cancelled out. That means 3x1 is equals to 3x2, and that means x1 is equals to x2. So that means I am able to prove, if I assume this thing, I can easily prove x1 is equals to x2. So that means my f is 1. So f is 1-1 function. Okay, so this is a one way. I mean, these two phrases are mostly used if you want to prove your function is 1-1 or not. And if you can easily see or observe that, okay, there exists some examples where it's not a, yeah, what is counter example? Okay, so counter example means, as we did in f of x is equals to x square. Okay, let me take some other function. So suppose f of x is equals to, okay, let's take modulus of x. So modulus of x means it will be x when your x is greater than or equal to 0, and it will be minus x when x is less than 0. So here you can take x1 is equals to 1 and x2 is equals to minus 1, right? Then what happened? Then f of x1 is equals to 1, right? Because modulus of 1 is 1. And f of x2 will be modulus of minus 1, which is equals to 1 again. So that means what is happening here? Here it says that x1 not equals to x2, but f of x1 is equals to x2. F of x1 is equals to f of x2. 1 is equals to 1, right? So that means for two distinct input, I am getting one single output, right? And this is not a definition of, this is known to be a counter example. Right, you are able to find out two x1 x2 which are different, but the output for these two different input is same, right? But the definition of 1-1, what does it says? It says if you have two different input, then you should get two different output. But here what is happening? You have two different input, but your output is same. Okay, so that is known to be a counter example. So that means f of x is equals to mod of x is not 1-1. Yeah, the fourth one is the horizontal line test. I will go to that also. Now these are the three ways you can check a function is 1-1 or not, and the fourth one is the known to be horizontal line test. So horizontal line test, what does it say? So it says if you have a graph of function and if you draw any horizontal line and if that line intersect with your graph exactly once, then that function is a one function. Otherwise, it is not one function. So that means if any horizontal line if any horizontal line intersect with the graph of f, graph of a function exactly once, then f is a one function. Okay, so for example, if I give you a graph of function, suppose this is the graph of function. So here you observe that if you draw any horizontal line, so suppose I'll draw any horizontal line, so then that horizontal line should intersect the graph of function exactly once, right? Because what happens if you draw any horizontal line, so that horizontal line, wherever it intersect, it will give you a pair of input and output. So for two different input, for example, this is your graph, suppose this is your graph, this is your f. But here what happen, if I draw one horizontal line here, then obviously this horizontal line intersect function, the graph of function exactly once. If I draw one, if I draw one horizontal line here, then this also intersect the graph of function exactly once. But if I draw one horizontal line here, then it will intersect my graph of function 3 times. That means what is happening for this input, for this x1, I'm getting the value to be y0, and for this x2 also I'm getting the value to be y0, and for this x3 also I'm getting the value to be y0. That means what is happening here, f of x1 is equals to f of x2 is equals to f of x3, which is equals to y0. So that means for three distinct output I'm getting one single input. For 3 distinct input, I am getting one single output. So that's why this function is not 1, 1. So this is known to be a horizontal line test. But this is applicable only if you know the graph of function or the graph of function is given to you. Okay. Is it visible now? So it's known to be horizontal line test. So horizontal line test means you have to draw several horizontal lines, and if one of them cut x-axis, cut your graph more than once, then you can immediately say that it's not a. Yeah, correct. And if a graph satisfy horizontal line test, that means if you draw any horizontal line and it will cut your graph exactly once, then that function is one function. So this horizontal line test can be applicable in both things. You can either show that it's not a one function, or you can easily prove that it is a one function because of the horizontal line test. Okay. Now let's move toward the another category, which is known to be onto function or surjective function. Okay. Horizontal line means any line which is parallel to x-axis. This is your x-axis. Then any line which is your parallel to x-axis is known to be horizontal line. Okay. Yeah, that will be your output. So now let's go to onto function. Onto or known to be surjective function. So surjective function, the definition is very clear. So suppose that means if the range of function is same as your codomain. So if range of f is same as the codomain of f, then f is onto. Okay, so onto function actually depends on codomain, whatever codomain is given to you. If we restrict our codomain to be range, then obviously it is an onto function. Yeah, you can just take x-axis also, because x-axis is also a horizontal line. So here x-axis is also cutting the graph 3 times. So obviously it's not a one function. Okay. So onto function means the range of f should be same as to a codomain of a function, right? Then it's known to be an onto function. Now, the range of function, if you want to find out the range of function, then it will be very tough to find range. You just have to use your intuition first thing. There is no general method to find the range, but via the graph you can judge the range. So I'll just tell you how you can judge the range of a function via the graph. Okay, so suppose a graph is given to you. So suppose one graph is given to you. So I'll take this to be your graph. Okay. So suppose this is your function f and this is the graph of function. Then what is happening, if you observe here that any point below this line is not get mapped by our function f. Okay. So if you assume any point which is lying below this line, so suppose you can assume this point, suppose this is, let's say this is -5, then there is no input for -5, right? Because this -5 is not a point a graph can touch, or any point below this, suppose this is, let's say -4. So then any value, any x below this -4, any y below this -4, because this is your y-axis and this is your x-axis. Right, so any y below this -4 is not, I mean, we cannot associate it, that particular point, as an input. I mean, there is no related input to these all negative values. So that's mean these all negative values does not have any preimage. So if I say that this is my function from real number to real number, then obviously for all real number, it is taking some value. So that's why domain is real number and codomain is again real number. So but the range of function is what? So the range of f is nothing but this, suppose I am assuming that this -4 is attained. For -4 there is some -2 is here. So the range of f is close interval -4 to infinity, right? All those values which are above here, and I'm assuming that it's going upward. Okay, it's not stopping here. I'm assuming that it's going upward. So any value from -4 to infinity have a preimage. So that's why the range of f is -4 to infinity. But anything which is lesser than -4 does not have any preimage. So that's why the range of f is -4 to infinity, and which is not equals to the codomain. That's why it's not a onto function. Okay, so this is a one way you can check it's a onto function or not. And the other way is just intuitively you can suppose a line is given to you. So suppose I'll give you one line. Suppose this is the line. Then you know that the line is actually coming from -infinity and going towards infinity. So here the range will be the all real number only. Okay. Yeah, I'll repeat this thing. So what happened? Range of a function, finding range of a function is a difficult task. You cannot easily find out the range of function. If the expression is simple, then okay, you can find out the range. But if the expression is very critical or involves so many things, then it's very difficult to find range. So what we do, we can find out a range of a function using graphical method for now time being. Okay. So suppose a graph of a function is given to you, then you have to observe that what values of y are not being assigned via some input, right? Here all values which are lesser than -4, then those values does not have any preimage or does not related to any input. So that's why they are not get mapped by a function. So that's why they are not in our range. So here our range is -4 to infinity. Okay. I'll give you one more example and I'll ask you via the graph, can you judge 2 to 3 properties of a function or not? Okay. So let me see. Suppose this is your graph and uh, this point is again, let's say this is some -5 or something. Okay, this is -5. I'll ask you 2 to 3 questions, and this is your graph of function. And you guys try to judge that what is happening over this function. Okay. So the first thing is I won't ask about domain. So I am assuming that this is my function from real number to real number. Okay. So first thing is it a 1-1 function or not? You can answer in the chat box. 1-1 or not? X to infinity means So obviously it's not a 1-1 function because it is contradicting our horizontal line test, right? If I draw one horizontal line here, then it will cut the graph of f more than once, right? So that's why it's not a 1-1 function. Now second thing is, what is the range of function? Range of f. Correct. So the range of f is nothing but -5 to infinity. Right. So this is the two things you can judge via the graph of function, the range of a function, and it is 1-1 or not. Okay. Now I'll answer whatever doubts you have. So raise your hand if you have doubt in 1-1 on two functions. And after that, we'll go to activity questions. Okay. Yes, Rohit. Yes, Dipankar, I will take your doubt also. Okay, let's move to Ayushman then. Yes, Ayushman, can you mute yourself?
Ma'am, I had a doubt in bijections and cardinality.
Okay. So bijective function means a function which is 1-1 and onto both. That function is known to be bijective function. So that means bijective means which is 1-1 and onto. And the bijective function actually used for computing the cardinality of two sets. So suppose you have a set A and B, and if a function is there, suppose f is a function there, and if f is bijective, then this actually implies that the cardinality of A and B are same. So this is a result, and this can be immediately follow from 1-1 and on to thing, right? Because 1-1 means for every element for the two distinct input, I have a distinct output. So that means one element is associated to other, and onto-ness will give us that the codomain is same as range. So that's why this cardinality is same. So whenever you have a bijective map between two sets, then the cardinality of these sets will be same. Okay, is that fine?
Can you give an example of example expression which satisfies both 1-1 and onto?
Yeah, you can take any line. Suppose f of x is equals to any line. Suppose I'll take 5x plus 6. And it's a line, right? You can easily check that it is 1-1 as well as onto. There are so many functions which are bijective function. A line is bijective. You can take f of x is equals to x cube. Then this is also 1-1 onto function, bijective function. Okay.
Can we generalize this? Like, yeah, I understand there is 5x plus 6 is bijective, but which is it's not the same case with x square 5x square
Yeah.
plus, right?
Correct.
So is there a way we can and again x cube is a bijective function, so is there a way we can generalize by looking at the expression?
Actually, we cannot, because what happened as you increase the degree of x, it eventually go into polynomials, right? And polynomials most of the time they won't be bijective function. So what you can do, you can learn the graph of polynomials, which we will cover in week 4. So there you can see, but we cannot generalize actually. You can generalize for lines that okay, every line is every expression of a line is a bijective map, and for this quadratic function also you can generalize that every quadratic function is not a bijective function, but for cubic and all those higher powers we cannot generalize.
Okay. So given a figure
Yes.
out easily without going into the graphs and all in a quick time, how can we figure out whether a function is bijective or not quickly? If we know the expression, is there a fixed way to figure it out other than
No,
graphs?
Other than graphs, I don't think there is more efficient way to find out the function is bijective other than graph.
Okay.
Graph is the more efficient, but via the expression you cannot judge. Via this simple expression you can judge, but if I give you more complicated expression, then it's very difficult to judge.
Okay, thank you.
Yes, Dipankar.
Ma'am, am I audible?
Yeah.
Ma'am, can we come to the conclusion that all the one-to-one functions have 1 0 only?
Sorry, what?
All the
Yeah. One-to-one function has only 1 0. Yeah, I'll come to that conclusion in the week 4 because there we discuss polynomials and there we discuss the concept of zero and all. Although it's quite obvious. So suppose, I mean, since you don't know the precise definition of zero, but suppose you have two zeros. So suppose you have two zeros. Suppose f has two zeros. Then what happen? F of x1 is equals to f of x2 is equals to
Yes,
0.
ma'am.
So that means for two different input, you are getting same output. So obviously it's not 1, 1. But for onto, I cannot see immediately. I mean, I need to look at
Can
the
we use
bar.
this method to check if a function is 1 to 1?
Yeah, you can check. If your function, if you are able to find out zeros, then obviously. But finding zero is again a difficult task. Via the factorization method, it's easy, but other than that, yes.
Ma'am, my second doubt is what does it mean by codomain equals to the range of f in a graphically?
In a graphical method, codomain, that means you have some restriction. Suppose here, if I in case of real number, I'll take my codomain to be -5 to infinity, then this negative axis won't be there. I mean, they will erase this negative axis at this time. They'll give you just like that, but this thing cannot happen in graphical method. Whenever a graph is there, we already assume that the codomain is real number. Although there is precisely mentioned that your codomain is -5 to infinity. That much change can happen in graph. Other than that, everything will be same.
Okay,
Madam, you explained that conditions, I think the point 2, point 3, something. So f of x,
Yes.
yeah. So that one total confused actually. So can you please repeat?
Okay.
So f of x1 equal to f of x3. So here, so the second condition, the only second and third, only you are changing the sign, not equal to, and below one is equal to. So I don't understand
But below
here
one
how
is
you
the, I
are.
mean, see, here the implication sign is this way, right? Here, this is the implication sign, this way. Okay, but here what has
Okay.
happened? This is my hypothesis. I'm assuming this quantity, and then I'm implying this thing. So that's the difference. Here, what happened? You can assume that, okay, so this is P implies Q type of thing is there. But here, what is happening? Minus of Q implies minus of P. That means I am negating a statement, and then I am reversing the sign also. So that's the one thing. That's why these two statements are same.
So that conditions you are explaining for only for the sign, right? Same number with a different sign.
Yeah. Because
Okay.
actually what happened, this equality, I mean, handling the equality is easy in case of handling inequalities.
Madam, is
In
it
some
see
cases you find out
here
that
here
it
the
is
condition 2 and 3, if you are proved, then it is a
1 function.
1 function. But here both area you are mentioning f of x1 and f of x2. Here also f of x1, f of x2. The only the not equal to and equal only is the different. So the both condition, see here you are telling equal, here you are telling not equal. So I don't understand this concept.
See what is happening here. Here they say first assume x1 not equals to x2 means you have to take two different input.
Is
Two
it
different input, you have to say two
sorry
different
to interrupt. Is it possible to give one example so I can understand, because
yeah,
the
I did
notation.
this example here, right? F of x is equals to 3x plus 2. Here
Okay.
first I assume x1 not equals to x2. Here first I assume x1 not equals to x2. This is
Okay.
my assumption. And from there I conclude that f of x1 not equals to x2. But in the second way, what I did, I assume f of x1 is equals to x2. And then I conclude f of x1 is equals to x2.
But here
So
the
that's a reverse thing.
here you are writing same notation here. So I don't know how
Okay,
the
so in
calculation is
place of
coming.
x1,
See,
x2,
for example, below, madam, below.
okay.
See, you can. So x1, see, you are derived, no, right? Yeah. So x1 is not equal to x2. Then you are including 3 both sides.
Yeah.
Then you are adding 2 in both sides.
Right.
That function directly is coming. So we people to
Huh.
understand that point actually. So
So see why the function is coming in picture, because if you put x1 here, then the value of f of x1 is nothing but 3x1 plus 2, right? F of x1 is nothing but 3x1 plus 2. That's why
okay.
this function is coming here. Although
So
I'm
below,
yeah.
below one also you are doing same
Doing the
thing.
same thing.
Same thing.
Right.
The only the symbol only changing, but both condition are proving it is 1 to 1 to
1
1.
function. Right. Why I show these two things, because sometimes this is very easy to apply and sometimes this is easy to apply.
Okay, it is
So
only
that's
for
why.
the sign purpose plus same number with different signs.
You can say that, but here hypothesis is different, right? So you have to remember it very carefully. So first you have to assume this quantity and then you have to prove this. If you do the other way around, then it will get a mess. Okay.
Then first point, what is the first point actually? So
first point is just a counter example. That means you are finding some x1, x2 which are not equal, but the output is same, as we did for f of x
okay,
is equals to x
input
square.
is not equal, but output is same.
Output
Okay.
is same. So that's a counter example thing. Okay.
Okay. Okay.
Yes, Karthik. Aryan, you can unmute yourself.
No.
Yeah, if domain is natural number, then you have to include 0. Yes, Aryan.
Ma'am, basically function is an expression where we put a domain having a domain codomain range, and if range having a if range range each element are unique for every domain, it's onto, right?
I mean, every codomain has a pre-image, then it is onto. That means range is same to be codomain.
And for one every range have its like every range have its codomain for onto.
No. For onto means range and codomain should be same. That is the meaning of onto. That means every element which is codomain, that should be in range. That I think you are saying, right?
Every element has compulsory to having a pre-image.
Compulsory to having a pre-image in case of onto. Okay. Okay, so if anyone has a doubt, they can unmute themselves.
Ma'am, I have a doubt.
Yes.
Ma'am, to check a function if it is onto, we can make x in terms of y, then we can judge if it's onto.
That's another way to check in place of x. I mean, there are, I think there are question based on this thing. For example, if you have a function f of x, someone asked in chat also, suppose something 27x plus 3 upon x minus 2 type of things there. So then if you have to judge that this function is onto or not, then what you will do, just change x in terms of y. So that means here it's given that y is equals to 27x plus 3 upon x minus 2. Now just do some calculation and convert it into x is equals to some expression of y. And from there you can judge what are the possible outputs or not. So this is one way to finding out the limit, finding out the range. So I'll come to this method when I'll see some question in the activity. Okay. I'll explain.
Put 2, right?
Ma'am, can you confirm me is every quadratic equation is not 1 1?
I can say that every quadratic equation is not 1 1, because the graph
Then
of quadratic equation is some parabola only, and parabolas are not 1. Yes.
no, what about if the quadratic equation has a repeated roots?
A repeated root, then also it is not 1 1. You will see this result in week 2. There we in detail discuss the parabola. There you can easily check that every parabola is not 1 1. You can easily find out 2 points where you will get same output.
Okay.
Anyone else has any doubt, or shall we move to activity?
Ma'am,
Yes.
will you explain the equivalence class?
Equivalence classes means no, because equivalence classes is not in your syllabus, so don't go there.
And in equivalence relation, ma'am, sir has explained one modulo arithmetic.
So modulo is there. So modulo relation is an equivalence relation because it is both. I mean, it is reflexive, symmetric, and transitive. And the second one, I think divisibility is something else. That will also equivalence. Equivalence means three properties should satisfy: reflexive, symmetricity, and transitive. That's all.
And ma'am, what does it mean an equivalence relation partitions a set?
Uh, all those things are not in your syllabus, so I won't explain them here. But if you want to learn, you can take any real analysis book. There you
Then,
can
ma'am,
find out
in
it.
function, many graph also in the lecture video. All those are in syllabus.
Many graphs. Which graphs you're asking?
Ma'am, in lecture video, sir has taken 2 to 3 graphs example in function.
Okay, so I'm not. Yeah, graphs are there, so graphs are okay. I mean, they haven't take. They will take either lines. I mean, they have take either lines or parabolas. That's all. Other than that, they haven't taken anything else.
Okay, ma'am.
Okay, so let's move toward the activity question. So I'll go one by one. I'll share my screen, and then you guys can say which question do you have doubts. Okay. Sorry.
Ma'am,
Yes, Sharesh.
ma'am, I just have a doubt. Like, how do we if it like there are some questions wherein like we get like x and y belongs to R and x is greater than y. Means if it is greater than instead of equal to, if it is greater than, then how do we check for functions?
Greater than y for function, I don't think such kind of inequality is there. You can mention the specific question number, then I think
Ma'am,
I will.
that is in the graded. That's why I didn't specifically say.
Okay.
If you go in graded,
X
there is one
greater than
question
y.
there. But as a concept,
I'll
Ma'am,
see that question. I'll try to
you
explain.
can
Yes.
explain
typically it's
from
the sixth
that
question graded.
Sorry, what?
no, ma'am, you can explain that function activity one by one. So it will, that concept what you explain, so it will be easier to understand with the concept what you explain now, ma'am.
Okay. Yeah, about that question, Kapil, I'll give you a hint. I'll see that question, whatever graded question is that. X is greater than y, some inequality is there, then it's very difficult to say a function is there. Okay, but I'll see and state it. So let's go to activity 1.1. My screen is visible, right?
Yeah.
No.
Okay. Just 1 second. So first
Excuse me,
question is
ma'am.
easy. I don't think here you have doubt.
Ma'am,
Yes.
function starts from 1.9.
Madam, select 1.11, madam.
Ma'am, I have a doubt in
1.9.
practice assignment.
Yeah, start from back side.
Okay, so we'll start backwardly. Then it will be
Yeah,
better.
backwardly it's better.
So I'll start with practice assignment, and then we'll go up to 1 point. I think 1.1, 1.2, these are very basic.
From 1.9 is the today concept what you taught me.
Okay, fine. So let's go toward the practice, and then we'll reverse it back.
Ma'am,
So
question
here,
second.
okay, question number 1 is no one has a doubt, right? So I'll move to question number 2. Okay. So question number 2 is what? So let A be the set of natural number less than 6 whose greatest common divisor with 6 is 1. B is set of the cardinality of A, B, A union B. This is an easy question. I mean, option is not okay, fine. What is the cardinality of A, B, A union B, A intersection B? What's your doubt in this? I mean, you just have to build a set. First, you have to say what is your A.
मैम शायद बिल्डअप नहीं हो पा रहा.
I think it's also related to the function questions we can go, madam.
Then go with the
Okay,
function.
okay, fine. Then we start with 1.9. Is that fine then?
Yes, ma'am. Yes, ma'am.
Yes.
Ma'am, if
Madam,
we could start with the
1.11,
same, ma'am,
if
it's
you're
fine
going, that's
actually.
good.
If you could start
1.11.
with the same, it would be good, ma'am.
Okay,
Ma'am,
fine. So let's go to 1.9.
ma'am,
Because a lot of inputs here, ma'am. Can we start with only one?
Yeah, just start with this. I'm not shuffling up.
ma'am, I
You just
have a
start
doubt
with
in
1.9.
1.9 fifth question.
Okay, first I'll go one by one. Otherwise, I'll just jumping in between questions. Okay. So first question, I'll explain all the questions. So first question is easy one. You just have to find out f of
Easy,
t,
ma'am.
right? The second one is domain range, but again, it's if you draw the graph, it's very easy to find out the domain and range of this function. Okay. The third one is also not that easy, but yeah, via the graph you can say. Fourth one.
Ma'am.
Ma'am, please explain the third one.
Yes,
Third
ma'am.
one you
Please
want to
explain the
explain.
third one.
Okay, so the third one says that you have given a function in modulus of something. Which of the following is true? First thing is injective, surjective, bijective, and none of this. So obviously we just have to check injective and surjective. Now here modulus is there, right? So whenever modulus is there, you know that since the codomain is the real number, this is your codomain, right? So codomain is real number and modulus is there. So that means f of x will always be greater than equal to 0. So that means all negative real number does not have any preeminence. So that's why it's not surjective. Now what about injective? So can it be injective? Since the modulus function is there, we know that if we take any negative value and any positive value, that two values can go up to the same thing. So here I just have to judge what the value of x I can take, which will give me a negative and a positive, right? So here if I take x to be equals to let's say 4 is there, so I'll take -5. If I take x is equals to -5, then this will be negative and this also negative. So negative, negative, positive. Okay, and if I take x is equals to 5, then
I mean, you just said
yes,
x cannot be less than 0. Then why we are taking minus?
x can be less than 0, but the domain is a real number. The value of function cannot be less than 0 because it's a modulus thing. So any negative, positive, any negative quantity will jump to positive quantity. So for injectiveness, what you can do, we have to find out some x1, x2. Oh, +1 -1 is working. Okay, so let's take x is equals to 1, x1 is equals to 1. Then f of x1 is equals to what is this? This modulus of 5 into 4 minus 10 will be -6. So that will be -6. So that means 30 is there, right? And x2 is equals to -1 if I'll take, then f of x2 is equals to -1 plus 4. That will be 3 into 6. No, it's not coming the same value. That's the thing. Now output should be same. So one thing you can do, you can plot the graph. That will be very easy.
Ma'am, can we not
checking.
put fx1 is equal to fx2?
If you put f of x1 is equals to f of x2, then how can you derive that it is a 1-1 function? F of x1 is equals to f of x2. Okay, fine. So that means that modulus of x plus 4 into 4x minus this is x1 minus 10. This is similar. I mean, the calculation will be very tough. Okay, so that's why I'm thinking about the graph. That it's okay if we go with the graph. Because graph can easily see that it's 1-1 or not. Although we can, via the observation also, you can take some values. But for time consuming.
Madam, in the exam, we can see the graphs.
In exam,
Yes,
you cannot. In exam, Desmos is allowed? I don't think so.
No, ma'am. No.
So here, although it's a modulus graph, so it's pretty intuitive that it should not be 1, 1. Right. So here you observe, if you draw one horizontal line here, so if you draw the horizontal line named to be y is equals to 10, right? Then this horizontal line actually cutting to 4 points. And although it's a modulus graph, so intuitively it's not, it should not be equal to 1, 1. But again, you have to think about values. So here, if you put as I put 1 and minus 1, you can put 4 and minus 4. Then you will get the same value. No, not 4 and minus 4. There should be something else. This minus 4 or something. Okay. So many values are getting, we are getting output to be 10. So that's why it's not a.
Ma'am, in the exam, if we don't get graphing, then how we will be able to plot this answer, ma'am?
Ma'am,
Yeah,
we can
but
think
in
it was
exam,
a modulus that for some real value it will give particular same
it will
value.
give you same value. So from modulus
X
also
square.
you can judge. But the next thing is, in exam we won't give you such a complicated expression in modulus.
No, it is
Obviously,
x
the graph
square.
of this
X
is very.
into 4x will be 4x square that way. So if it is x square, then definitely it will not be.
Okay. Also, if x square, sorry, what?
X into 4x is 4x square, and if it is a 4x
So it is.
square, obviously it will not be 1 to 1. Anything x is
Yeah,
not.
via the quadratic also you can say that because of it coming out to be a quadratic function, it's not 1, 1. But because if you solve this, it will be 4x square minus of 2x minus of 40 is there, right? So it's a quadratic expression under the mod. So now the graph of this function is easy. Now in the week 2 you will learn, but this is not in week 2, so that's why.
Madam, better you just copy the question and paste it in that whiteboard, so you can explain, madam. So it will be the notes also we can use so in future.
Yeah, right. But that will take so much time. That's why. And that
No,
board does not
just
support copy paste thing.
no, madam. Just press Shift Windows yes, so it will you can copy.
Yeah, I know. You are talking about the screenshot now. Just take the
Yes,
screenshot and then paste here in the.
yes.
Yeah, but actually that takes so much time. I tried last time and it just won't work that fluently.
Could you
But
please
although
try?
you are
I'll
getting
get.
all the.
No, madam. Now the steps we are writing now, so we can understand, because if, instead of speaking, yes, if we are writing, so we can easily you can catch up points.
Okay, fine. I'll do that.
So you
I'll
can
take the
press
screenshot
Shift window yes.
Yeah, got what you want. So that means just take a screenshot and then copy and then paste in the
If you're
OneNote.
pressing
That's the thing you're doing.
Shift window yes, so it will prompt for the selection. Once you selected area, then you can paste in that whiteboard.
Paste in that. Fine. I'll do for next question. This one is okay, right? This third one. I'm not looking at chat box. Sorry for that.
No, madam. How you are explaining, I'm totally blank actually.
Yes, ma'am. We didn't getting that.
So better you can write,
Okay,
madam.
Okay, fine. I'll just stop sharing from.
The same OneNote you can paste, madam. No issues. Same OneNote you can paste. So it will we can paste the image also once copied.
Okay.
Excuse me, ma'am.
Yes.
Ma'am, actually in question number 6 of exercise 1.9, I was having a little bit doubt. I was having doubt in question number 6.
Ma'am, in question number 4, I had a doubt.
Ma'am, in 5.
Okay, so question number. So yeah, just tell me which questions are 4, 5, and 6, right?
Yeah, fifth ma'am, in fifth na the means I don't have real ऐसा, but if you see na the first option fx root of 10 minus x. Can you share the screen, please?
Yeah, I'll share and also I'll just copy all the questions.
Yeah.
Then
or copying all the question maybe will maybe struggle, madams. What I'm telling now, if you are following, that only easy for you.
Okay.
Can I get it now? So can you share the screen? So
Yeah.
okay. That's
This
it.
thing what you want, right?
Yes, that's it, madam. You can solve now. So
Uh-huh.
I can understand.
So, okay. So for surjectivity, we answer that since it's a modulus function, right? Mod is there. F of x will always greater than equal to 0. And the codomain here is the whole real number, right? So that means obviously the codomain and the range is not same at all. So that's why F is not surjective. Right. Now for injectivity, what I want, I observe that again, f is a modulus function. And the graph of modulus function, suppose if you have a graph of f of x is equals to modulus of x, then you observe that the graph of this function something look like this. That means whatever quantity will give us a negative value, that automatically jump into the positive section. So what I want to say, so suppose you have f of x, I mean here you have f of x is equals to modulus of x plus 4 into 4x minus 10, right? So now we have to find out two input in such a way that the output is same but the input are distinct. So what I can do, I can find out the value of x1 and x2 in such a way that first thing is f of x1 should be negative and f of x2 should be positive, something like that I want. Okay, although it that one thing someone point out, if we have more than one zeros, then also it is not injective. So we can use here also. So if you take x1 is equals to minus 4 and x2 is equals to 10 by 4, that means I'm just taking this bracket is equals to 0, this bracket is equals to 0. So then what I'll get, if x plus 4 is equals to 0 means x is equals to minus 4 and 4x minus 10 is equals to 0 will implies x is equals to 10 by 4, right? So if you take x1 is equals to minus 4 and x2 is equals to 10 by 4, then your f of x1 will be equals to modulus of minus 4 plus 4 and with this bracket and then mod. So that means this is equals to 0 and also f of x2 is also equals to 0. So that means here what I am getting x1 not equals to x2, which is minus 4 and is not equals to 10 by 4, will implying f of x1 is equals to f of x2 is equals to 0. So this can imply that f is not injective. Now I
What
think
if
this is the simplest way.
what if it was not modulus? Can you work it out?
If it is not modulus, then also it is not injective, although because it will be quadratic. And that thing you can, by parabola, if you know the parabola, how parabola behaves, then you can easily say that if modulus is not there, then also it is not 1 1 on 2. If
Okay.
modulus is there, then also it is not 1 1 on 2. But if modulus is not there, then also it is not 1 1.
So 1 on 1 is injective, huh?
1 1 means injective, on 2 means surjective.
Excuse me, ma'am. When we will do
Yes.
question number 6? Actually,
Yeah,
I was
this.
having doubt in question number 6.
Yeah, this is your question, now question 5 and 6. I just copy pasted here.
Question 5
So
only,
question number.
question 6.
Question 5 also.
Yeah.
Okay, fine. Yes. Here given that x belongs to real number, domain of f is all x belongs to real number, f of x. Here this definition of domain is given. Don't worry about that. So which of the following function is are injective? Okay, so we have to answer injective functions. So here, obviously this is square root function, it will be injective. You can easily check via the definition, because obviously if I take x1 not equals to x2, it simply implies 10 minus x1 not equals to 10 minus x2, and this will also implies under the root of 10 minus x1 not equals to under the root of 10 minus x2. That means f of x1 not equals to f of x2. Right, so that means it is an injective function. It's quite obvious. Now this one also you can say that here if you just simplify it, it will become 7 by 3 plus 6 by 3, that means 1 by 2x. And here also you can use the same definition. You can use this definition x1 not equals to x2, and you can easily prove that this is also a 1 1 function. Again, this is equation of line, this is also a 1 1 function. This is not a 1 1 function, you can check it out. So I'll leave this particular expression to you. Not 1 1.
But it
All
says
these three are wrong.
fsx is a real number, but when we put x value more than 10, then it is a
Then
complex
obviously
number.
it is a complex number. So that's why they have given the definition of domain. You have to take all those x for which f of x belongs to real number. And also you can put the input only if the function is well defined. Other than that, you can't. Right? Is that fine?
No, didn't understand that.
So
Ma'am,
in
please
first
explain
option,
option
if we put x value, let's say 11, right? Then
No, you
function is
cannot
no.
put because function is not defined. That's why you cannot put the value 11.
Yeah, ma'am, exactly. This is my doubt. In the first thing, function is not defined. But if you see the answer, na, they say ki this is correct function. Means they're saying this is a one-on-one function. Whereas actually, if everything is real, so this can't be real, right? We have
Yeah,
restriction.
but see here they haven't given the domain of f. This function is actually defined from all positive. I mean all real number greater than equal to 10 to real number. So here whenever you talking about injective function, don't bother about the domain. Okay, just go with the expression and find out if you are able to find out x1 x2 which are for which our function is well defined, and then go ahead.
Yeah, okay.
Because
Means
already
I was
mentioned that
getting confused with that because first of all, I mean technically this can't be defined as a function because that
right.
so that's why I got doubt. Okay, ma'am. Yeah, that's it.
Is that fine for everyone?
Second option.
Second. Ma'am, we can
second
also do
option.
from calculus method also, no? That
Which
first
calculus
question, that answer is that it is injective, that fx is equals to root under 10 minus x. If we proceed through calculus method, no, answer is coming right.
Calculus method means which method you want to?
That after doing differentiation and checking whether it's
Don't go there. A differentiation now we haven't taught you, so I'll suggest without differentiation try to apply whatever knowledge we have now.
Okay, ma'am. And ma'am, till now we in function we have not read about that one function. I'm saying that signum and all. Are they going to come in exam?
No. Such type of function won't be there in exam. If we
will
want
not
that sigma function we don't ask usually, because it's nothing. That sigma function is simply a function defined in this way: one value here, one value here, and then all other value here.
Ma'am,
So it's okay. It's a particular type of function, but we don't bother about it.
Ma'am,
Yes.
are we going to cover that in our syllabus in upcoming weeks?
No. We won't cover any specific thing about sigma function. We just play with general function theory and calculus.
Thank you.
In this question, this domain of f of x belongs to R. Shouldn't we take entire
Yes.
R?
No. All f of
domain.
x belongs to R such that.
Okay.
This line is here saying that such that f of x belongs to R. So you have to take all those real number for which your f of x belongs to real number. This is a set comprehension notation. Na? So here R is the existing set.
Yeah.
This is your existing set, right? And we have to select all those real number for which the value of function is real number. That's the definition of domain, right?
Madam, for the first option, since it is root x is there, then it will not be injective now.
No, it will be injective because if you draw the graph also, here we prove that it is injective, right? If we take x1 not equals to x2, then 10 minus x1 not equals to 10 minus x2, and square root is also not equals to that. So that means f of x1 not equals to f of x2. So here we show that if we take a different input, we are concluding that our output is different, and that's the definition of one function. And although square root function is injective, you can check it via the horizontal graph also. The graph of square root function is this. This is the graph of square root function.
Okay.
Square root of x. Here little shift is there, so you can just adjust that. Okay. So this option 1, 2, 3, 4 clear. The 4 one, it's not 1. I'll just take it to be as a homework. You can find out some x1, x2 for which, or else you can do the same thing as we did earlier. Just take x to be in such a way that the function value is 0.
Hence quadratic again.
Quadratic also. Although you can take these two values. Just take x1 to be equals to minus 4 by 5, which will make this bracket 0, and take x2 to be 3 by 2, right, which make this bracket to be 0. Then your f of x1 is equals to f of x2. Then your f of x1 is equals to f of x2 is equals to 0, right? So that's why this is not a 1-1 function. So is this question clear to everyone? Shall I move?
Yes, madam.
Yes, ma'am.
Yes, ma'am.
Fine. Yeah, we are running a little slow, but it's okay. We can discuss all the doubt in next session. We have 3 sessions.
Ma'am, in question number 4.
Question number 4.
Yes, ma'am.
Okay.
Question number 6 once explain the last one.
Ma'am,
Yeah, I'll
as you
explain
said,
question number
range.
6 and then go to question number 4.
Ma'am, as you said, range is a function of range of a function is subset of codomain.
Right.
But in question number 4, it is not accepted as answer.
They
This
asked a
should not happen.
wrong option. In the
Range
question
of
they
a
asked.
function is a subset of codomain. Yeah, false is there, na? So you have to select false options. Which of the following are false? Okay. So now let's solve this. So suppose f is from integer to integer is function defined by f of x is equals to ax plus b. For which of the following integer values of a and b is given is the given function bijective? Okay. So now if you suppose just put the values one by one. So if you take a to be equals to 0, then what happen? Your function f of x is just a constant function b, right? And if you take b to be any number, so here it says b is equals to all z such that z belongs to integer. So that means you can take any integer. So suppose I'll take b is equals to 5. Then my function is what? F of x is equals to 5. And this is a constant function. And we know that constant functions are not injective. Because if you take any value of x, you will get the same value 5. Right? Because if I take f of 1 is same as f of 2, is same as f of 3, is same as, and so on, is same as 5 only. Well, it's a constant function. So that's why it's a not injective. So it is not 1-1 or inject, right? Now about the ontoness. So here the function is f of x is equals to 5 and the codomain is the set of all integers, right? So that means only one number, only the integer 5 or only the integer b is taking the value, has the pre-image. All other integer does not have any pre-image or does not associate it to any input. So that's why also this function f is not surjective. So if I take option number A, if I select the values of A and B from my option number A, then my function is not injective, neither injective nor surjective. Okay, so this option is not. Is that fine, this explanation?
It is not injective, that we understood, but how is it not subjective, you are saying?
Because see, here codomain is the set of integer. But if you take any constant function, if you fix the value of b to be any integer, then only that integer will get mapped. What will be the range of this function?
Okay, range is
Right?
only
So the
5.
range is singleton 5, right? So that's why it's not equal to the set. Okay, fine. So this is one thing. So it's not
Ma'am, then option number C will be also cut, no? Option
number C is also cut. Because b can be -1, again it will be a constant function. Because if you put a is equals to 0, this x will gone, right? Only b is there. And if you put any value of b, then it will eventually become a constant function. And when a constant function is there, then the constant function is neither injective nor surjective, right? So that's why this two option will get cancelled. Now let's suppose I'll suppose the value of a can be -1, because here see what is asked to us, that for which of the following integer values of a and b is the given function is bijective. So that means we have to select some values of a and b for which my function is bijective. So now in the option number 2, it's given that a is equals to -1, 1. They should be written a belongs to, not a is equals to, but okay. And also b belongs to, because obviously these are integers and other ones are sets. So, but it's okay, fine. And here it says b belongs to that all set of integers. Okay. So here if I take a is equals to -1, then and b is equals to any integer. So for time being, let's take 5 only. Okay, you can take any integer, but for now, let's take 5 and observe what is happening. So then what is my function? F of x will be minus x plus 5. And what is this? This is an equation of line. Right? And this thing you can easily check that in this case, f will be 1, 1 as well as on 2.
Right.
Right? Because it's just a line. You can easily check that the equation of line is always 1, 1 and on 2. So if I take a is equals to 1, then my function is bijective. Now suppose if I take a is equals to if I take a is equals to minus 1, function is bijective. If you is equals to 1 also, and b to be any integer you can take. It's not necessary to be 5. You can take any integer. But also if I take any integer, again, it will be an equation of line. Right? And we know equation of line is always bijective. So that means f of x is equals to x plus anything b. B could be anything. But first we have to fix b and then we will talk about function. Okay. So here again it's a line. Right. So it's a line. Why I'm saying that a line is 1, 1 onto, you guys are familiar, right? Because if you draw a line, it will be a straight thing. So
Only one
right?
horizontal line. No horizontal.
One horizontal. So horizontal test via also you can check that it will be 1, 1 onto.
Ma'am?
So that means our option number 2. Yes, 2 is correct, right?
For the constant function, the x becomes 0. That means the domain is an empty set.
No, domain is not an empty set. You can take any value, but the outcome will be 5 only, right? Because there is no involvement of x. There's no restriction on x, right?
So more
So
than
for
constant,
Ma'am, can you explain what is horizontal line test once more?
more inputs and only output only one number only. So
one
it
number,
is,
singleton number.
yeah, so it is not a function itself,
Inject.
bijective or subjective.
It's not bijective. So horizontal line test means if any horizontal line cuts your graph exactly once, only once you want that horizontal line cut to your graph. If this scenario is happening, then you say that your function is 1. That's a horizontal line test.
Okay, ma'am. Thank you.
So now,
Ma'am, I
so that means this option is correct. Yes. Yes,
fourth
Lokesh.
option is also right, ma'am. I think.
Fourth option, what does it say? Yeah, again, it will become a line. If you take any a, because since b is equals to 0, your f of x will become ax. Now, if you fix any value of a, then again, it will be a line passing through origin, right? And via the same thing, line is injective, bijective. So that's why the fourth option is correct. Okay.
It's MSQ or MCQ?
It is only
But in
single
answer,
option, ma'am.
Can be only one option
fourth
correct.
option is not there.
Fourth one is not there.
Ma'am, fourth option is not correct. Because if we take any integer.
Yeah. But 0 is there now. Okay, I missed 0 because if a is equals to 0 is also a choice. Right? Here, if you take a is equals to 0, then your function f of x will become 0 only. And again, it's a constant.
Correct.
I missed 0 here, sorry.
Ma'am, activity 10.
Can you explain that?
See, I think our time is up.
f is equal
Sorry,
to 0?
what?
Can you explain this?
See what? Yeah, I'll explain. So what happened in fourth question? It's given that b is equals to 0 and a can be any integer. Z belongs to integer. So here I assume that a is not equals to 0. But here is one possibility is there that you can fix a is equals to 0 and b is equals to 0. So if you do that, then your f of x will become 0 only. And again, it's a constant function, right?
Okay.
So that's why the fourth option is not correct.
If you don't mind taking one more question from activity 5.
Okay, so I'll take one more because since we just have covered one activity, right? So it's not possible to do
a equals to minus 1 comma 1. Does it mean that all the values between minus 1 comma 1 is included, or individually minus 1 and 1 is substituted?
Individually minus 1, because this curly bracket is there now and comma is there, but although curly bracket is there, so because of this curly bracket it's a set. Although if some close bracket is there, then it will be interval, right? So that's why you have to take only, although it's already mentioned that a and b are integers, so that also gives you
Ma'am, question number 3 that
1.5.
IIT Madras from activity 5, 1.5.
1.5. So I'll just take this last question, and after that you can ask your general doubt, and we can end our session. Because obviously I cannot finish all the activity today, right? Question number 2.
3.
5. 3.
Question 3.
Which of the following set represents students of Madras University who played cricket, basket? Okay. So what's your doubt in it's a is there any confusion?
Show the screen.
The question. Yeah, I'll show.
Yes, ma'am. The in sets there is doubt, and because the volleyball, basketball, cricket, both are given. I mean, 3 of given, and all names are in the option, so I'm unable to figure it out.
Okay, so given below is the set of students of Madras University who are going to participate. Only 15 students in Madras. Okay, so based on the our data, answer the question. So which of the following sets represent the student of Madras University who play both cricket and basketball? So this is a list of player who knows volleyball, right? Or who can play volleyball, basketball, and cricket. So here what they say, you have to find out which of the following sets represent the student of Madras University who play both cricket and basketball. So ultimately what you have to do, you have to take B intersection C. So who can play cricket also, and who can play basketball also. So if you take the intersection, then what are the common name? Charan
Ma'am,
is here, right? So
ma'am,
Charan, yes.
but there
Huh.
in the second line is given play volleyball, basketball, and cricket. Ma'am, V, B, C represent volleyball, basketball, and cricket.
Basketball and cricket.
Exactly, but there are all 3 rows in that, no? So how can we judge second is for only basketball? It could be first one, B could be
Actually,
basketball.
I think they have mentioned in this order: volleyball, basketball, and cricket. That's why they given in this list format:
Okay,
volleyball,
okay.
basketball, and cricket. Although they should mention that this is the set of all volleyball student, but yeah, it's we have to observe this thing. Is that
Respectively, they
fine
have
then?
said.
Ma'am, respectively, that's fine.
Respectively
Yes, said
is there.
respectively. Yeah, respectively means in that
Respectively is
order.
there, so then fine. Yes. What's your doubt?
Ma'am, can you
Ma'am, I had a
solve question
simple
5
question.
and 6 from this set only? I'm having doubt in that. First 2 are
So
given.
then you can answer in the similar way. So here they say that okay, fine. So here they say that both cricket and basketball. So you have to judge which one is both. Both means B intersections you have to do. If they say cricket
Third
only,
option is
basketball
correct.
No,
also,
ma'am.
be
Not
nice.
a, no, I'm not asking that both one. I'm asking question number 5,
Mhm.
which is which of the following set represent student from IIT Madras University who play volleyball but not cricket? And the
Volleyball
other
but
one.
not cricket they are asking, right? So volleyball but not cricket means V minus C you have to find. Volleyball but not cricket. So that means who are in V but they should not be in C.
Okay, ma'am. I
Clearly
got all
person who
questions.
don't.
Yes, yes. Now
Huh.
I'm getting. Okay. Thank you so much.
Ma'am, I had a simple question from activity 1.1.
1.1.
Yes, ma'am. Question number 3. Ma'am, do we have to count one by one in this question and then write the answer, or is there any short trick?
One that professor told us one greeting method, right? There you have to answer. I mean, there is one thing. They greet all 100 names and 100 numbers, 1 2 up to 100, and they are
Sleeve
cancelling out all the
operations.
multiples. So this they want to use this. You have to use this method and find out what is the whatever prime number they have asked.
So, ma'am, like in this question, if there is given any other question in the exam, we have to draw this.
No. We won't give us. Obviously, we take care of your time. We know how lengthy a question can be, right?
Okay, thank you, ma'am.
I wanted to say one thing. Since you told us that bijective
Yes.
functions are both injective and surjective, so can we say that if a function is not injective, it will also be not bijective?
Right. Because bijectiveness need both thing, injective as well as surjective. Both thing combiningly can say it's a bijective function. If it is one of them, then you cannot say it's a bijective function.
Okay, thank
So
you.
yes, you need both of them. Okay.
Ma'am,
So
you will
that's all from
provide
my
the
side.
notes.
I'll end the session. Yeah, I'll share this notes. Okay.
Practice assignment second question. It needs clarity.
Which one?
Practice assignment question number 2.
Question number 2. Yeah, I'll give the hint. And there is one graded question someone says, no, I will just check it out now.
It is not graded, and it is a very easy question. What you said is, so that the terminology which denotes over here, let A be the set of natural number less than 6, and whose greatest common divisor with the 6 is 1. What is that? The GCD with the
So
6
that
is 1.
means, so first thing is any natural number, I mean, you have to take natural number which is less than equal to 6. And then you have to compute GCD with 6. And that
It's less than or
it
not
should be
equal
1.
to. It is less than 6. So it is 1 to 5.
Strictly less than 1 to 5 you have to take. So if you take 1, then obviously GCD of 1 comma 6 is 1. So 1 will be there, right? If you take 2, then GCD of 2 comma 6 is 2, right? So 2 won't be there. Similarly, 3 won't be there, 4 won't be there, 5 will be there. So the cardinality of A should be 2, right?
Okay, so,
So
1
you have
comma 5 is
to, 1
set
comma
A.
5 will be there.
Where will share
Ma'am, I
this?
have a doubt.
Where will
In
you share
which,
this?
yeah, I'll share this notes.
How you are
Yeah, if
sharing?
you have doubts in
Yesterday's how you shared?
last in the chat box, I just downloaded PDF and send into chat box.
Yesterday's
Ma'am, please share.
Yesterday's one.
Yeah, I have yesterday's one also. I'll share both of them.
Can you share both?
Yeah, I'll share both. Yes, someone has doubt. I'm not going to solve any question now because I know I cannot complete it. So it's better if we do it in the next session.
And that practice assignment third question also a little bit tricky.
Okay, yeah, I'll explain. Third one. Just save it.
Ma'am, activity 10, question number 7.
Question number.
Ma'am, I think people are having more doubts because today's TA session was cancelled. If you can schedule one tomorrow, like only we have 2 classes tomorrow, and none of it is of maths. One TA tomorrow, then it will be very much helpful.
And both are timing together only.
Because we have the deadline on 2nd for first week.
So second also you can give, na? Second is a holiday for us.
Yeah, I'll say one TA session should be there.
Before that, we have to solve all our doubts of week 1. That is what I'm saying.
Yeah, right. 2 is the deadline for graded assignment, huh?
Yes,
ma'am.
I share the notes and then we'll discuss.
It's being shared in the chat, you're saying, right?
Last notes. Now I will share last class notes. Summary notes. This is open session is today notes. There is 2 PDF I'm sharing. One is open and the second one is summary. So summary belong to yesterday's session.
We got it.
Okay. So which question you are asking?
Practice 3.
Practice question number 3. So let A be the set of even natural numbers, B set of natural. So here Venn diagram, if a circle denotes a set, then all the elements, all the region inside that circle is our set. Let me share my screen. So what does they say? There are some restriction over A, B, C. And if suppose this is your Venn diagram, so this box is your universal set. So I think your universal set will be natural number. So there is some portion inside A, some portion inside B, and some portion inside C. So you have to judge which number comes into both. Suppose if they say A is odd, all odd natural number, and B is all even natural number, then obviously their Venn diagram should look like this: two different circles, right? Two disjoint circles. Because we know that
Yes.
odd number, even number does. So you have to use such kind of thing to judge which Venn diagram is that. Okay, is that fine? I mean, that will give you some.
Actually, it's intersection also is there, so that's why I'm
So
confused.
you have to see which sets can have intersection, or which sets. Suppose here they say that D be the set of all prime numbers less than 100, and B be the set of all odd natural numbers. And we know that all prime numbers are odd, right? So that means D is sitting inside B. The set D is sitting inside B. What does they say? They say that B is what? All odd natural numbers.
It won't sitting, actually it will intersect, I hope so.
D is all prime numbers, na? All prime number less than or equal to 100, right? So, but we know that
Yes.
all prime numbers are odd. We don't have even prime number, because any even number is
We
divisible
have
by
two. Number 2 is there.
Okay, 2 is there. So one intersection. All odd.
Yeah, that's what I'm saying.
Okay, 2
So
is there.
it
So
would be
then it will
intersect,
be
might be
intersect.
not
Correct,
be,
correct.
proper subset.
Right. So then it will be some intersection will be there. B and D. My bad. Sorry. 2 is there. So yeah. So you have to judge with this only.
Okay.
Okay. Any other doubt? If we have, then we will continue all the activity doubts in next session, because it's already 10:15.
So same
You guys, I think.
practice eighth question.
Practice assignment eighth question.
Eighth question. So just A, B, the relation would be there. B and A even non-zero integers. A by B is also an integers. So I can say it is
Which one?
so eighth one, the relations have been given. Okay, so if it is all are even integers, I can say it is directly transitive, as I can see only one element in my R. There is no comparison, so it is transitive. But I don't know why it is reflexive.
Because a comma
because
a
every integer
equals
is
to 1
divisible
and
by
it is an
itself, right?
integer.
If
Sorry?
both A and B are even non-zero integers. So if A is
Okay.
even non-zero integer, then A is related to A, because A is also divisible by A, right? So that means if A is what you say, even non-zero integer, then A is related to A, right? A comma A belongs to R, as we know that A divides A, because A by A is nothing but 1, and 1 is an integer, what he says, right? Because we want A by B is an integer, and we want A B are non-zero integer. So if A is non-zero integer, again A is non-zero integer. So that's why every element is related to itself. That's why it is reflexive.
But I thought A by B, so you can take 2 and 4. Like that is also possible. No?
But reflexivity says every element should relate it to itself. Yes, but any other pair also there. Na? What you are saying, you can take 2 comma 4. So correct, 2 comma 4 also belongs to here. Belongs to in here, but that does not contradict or reflexivity. What does reflexive says? Reflexive
So it
says
should be
that
2
for
comma 2,
all
4
A,
comma 4 should be there.
2 comma 2 4 2 comma 2 is there, 4 comma 4 is there, right? So yeah, they should have given the set A, but okay, fine.
That's
And
what
what
actually
is
it's not clarity
set
is
A
not
is?
there.
this A should they should given. What are they taking A? If they
By
take
default,
A to be, if we take
by
A to
default,
be
we can
integers,
see transitive easily.
transitivity is there because if
But
neither B is
reflexive
integer,
got little
neither
bit confused.
for reflexivity we need one set. Okay, but fine.
Ma'am, please take one
Yeah,
last
such type
question.
of ambiguity won't be there in question paper. Yeah. One what?
Ma'am,
This
activity
is last question I'm
1.6.
taking. 1.6.
Question number 3.
Yeah, we can do all the question later also, right? Because now it's time. I mean, it's already 10:18. And you guys already did one stats class, right?
Can you schedule for 2nd October?
Yeah, I'll try to schedule one TA session also, which will clear your all activity and practice doubts.
Ma'am, in question number 3, how is option 3 correct?
Which question number 3?
Activity 1.6, question number 3.
So question number 3, what does it say? Which of the following set comprehension define squares of first 100 natural numbers? So that means first thing is you have to take squares and then first 100 natural numbers. So the third option is correct here, right? So in place of n square, they just use n. So just think about it. It's not that tough. It's just written in rephrase way. In place of n square, they just take in n.
Ma'am, please,
And
ma'am,
they have
activity 10 question number 7. I'm unable to find the cardinalities.
which one?
Activity 10 question number 7.
Activity 10 question number 7. So P be a subset of S cross S minus R. What is the set of possible what is the set of possible cardinality of P? Yeah, so you have to see S cross S will be what? So S cross S you have to find, and from S cross S you have to subtract R, and then you can find out.
S cross S has, ma'am, 16 elements, and
S cross S will have 16 elements, right? 16 elements and minus R you have to do. So,
ma'am, 4 elements are
4 elements.
So, ma'am,
12 elements. What is the possible? So here options are little bit. I mean, we are getting exactly 12 to be cardinality. 12 is the answer.
Yes, ma'am.
So, what is the set of possible cardinality? This question is what? Yeah, exactly. I mean, we are getting the exact answer, right? But P here it's given that P is a subset of, not exactly. So it is a subset of. So the cardinality of S cross S minus R is 12, right? So if P is any subset, then its cardinality could be 0, 1, 2 up to 12. That's why the fourth option is correct. They are given subset of, right? And the subset can have cardinality up to the set. And here the cardinality of S cross S minus R is 12. So that's why the fourth option is clear. Is that fine now? This subset is creating the problem for. Let me share my screen first. See here, this subset is given, right? P be a subset of S cross S minus R. And the cardinality of S cross S minus R is what you have said is 12, right? So if you take any subset of this set, that can be 0 to 12. Fine?
Yes, ma'am.
Okay. So yeah, I'll end it with this. Fifth one,
Ma'am,
10.
5 will also be included.
Which one?
Ma'am, you mean 5 will also be included?
5 will also be included. What's harm with 5? Because it's a subset. Subset can have any cardinality, right? Up to the set cardinality. So here the set cardinality is 12. So that's why the P can have cardinality from 0 to 12.
Okay,
5 will be there.
thank you, ma'am.
Okay. Okay, so that's all. So if you have any technical
Hello,
doubts, you
ma'am.
can. Yes.
Can you just give me a hint of one question as it is in graded assignment? Question
Okay.
number 5.
Which one?
Fifth
Question
one.
number?
Fifth.
Fifth. Fifth. This Venn diagram is there.
Yes, ma'am.
So what's your doubt? Here what we have to do, find the number of ponds polluted by all types of water containment. So judge what this statement refer to which set. First thing is that judge uh, which sets cardinality you have to find. So here they say that all types of water. So all elements can belong to which set. It can be union, intersection, subtraction, complement, which thing can say that all types of water. So this all you'll get the answer.
Okay, ma'am.
Okay.
Thank you, ma'am.
Because huh. If you don't have anything to discuss, you can leave. I also leave by 10:30.
Thank you, ma'am.
Yeah. Thank you guys. Good night.
Thank you, ma'am.
Ma'am, when
Ma'am,
will be
how
the
we
next session
send
held?
doubts and discuss forums? Can you tell me, please?
You have your own profile, right? There is one match one group also. I mean, there is one match one site. There you can post your comment. So I think that is, I mean, that's the place you can ask about doubts.
Madam, how do we get
Okay,
the
ma'am.
notes for today?
Sorry, what?
How do we get the notes? Is there a document?
Notes. Yeah, I have shared two PDF in chat box. You can download it from there.
In chat box. I mean, is it? I don't see the PDFs actually. Is it in the chat box?
Yeah, I share to everyone only.
It's
Okay,
there.
I'll share again. Then you can
No,
do
it
it.
is not there, ma'am.
It is
It's
not there
Okay,
there.
I'll
actually.
share now also.
It is there.
No,
It is
ma'am, it is not there.
it is there in the
It
chat.
is
Check it.
there,
Ma'am,
ma'am.
those who
It
have
is
joined
there.
late, they will be not able to see the messages.
No, I joined
Okay,
early,
okay.
but I don't see it
Yes,
actually.
ma'am. Now
Anytime.
I am.
I will share again. It's okay. I have downloaded it. So I have shared one that belonged to summary. That means yesterday's session. Today's session is open. Although I think date is mentioned in PDF, so you can see. I have shared to everyone, so I think you guys can access now.
Thank you, ma'am. Thank you, ma'am. Just to.
Thank you, ma'am. Thank you so much.
Thank you.
The man. Hello, ma'am.